Yo.
I literally said, okay, let's get started. And then you jumped.
No way.
Yeah, you missed the you know what session beforehand.
A little bit of therapy.
Oh yeah, a little therapy session. Okay. So this whole unit, to be completely honest, kind of sucks. It's just a lot of raw memorization. Like, there's a lot of medical conditions, and then like specific, like, oh, like this turns into this, and this breaks down into this, and these things get put together to make this. So, yeah, we'll try and get through as much of it as we can. Okay. So, a defect in which the following enzymes can result in alkaptonuria. So, alkaptonuria specifically is phenylalanine and tyrosine degradation, which can lead to alkaptonuria. The defective enzyme is homogenistate oxidase, also known as the homogenisate 1,2-dioxygenase. Again, like a lot of this is just going to be like matching. Like you have to know which one goes with which, and then the symptoms of them. So with this one, causes dark pigmentation. You literally get black urine. A good chunk of these are going to be the type of conditions that pop up on boards. So these are important to know long term, just an FYI. So this is the homogenistate gentisate oxidase. Let me actually see if we'll just stick with the individual ones. Here we go, alkaptonuria. This is another one of this. So like I said, you're going to see questions kind of bounce back and forth just like this. Defective phenylalanine metabolism. And this can be fatal for patients. So typically it's caught. You'll see these are most likely conditions that you will literally never ever see. But
you could.
But you could. So it's defective phenylalanine metabolism. It's also at an tyrosine, so if that pops up there as well. And then this stuff, catabolism of which of the following types of amino acids produces acetoacetyl-CoA? With, again, a lot of this is just going to be kind of the memorization type stuff. These are going to be our ketogenic amino acids. I really wish there was a better way to do this, but like even like the book and like I made a whole prep thing for this unit. It's literally just, hey, look, this turns into this, which turns into these things, and this turns into this, which turns into these things, and this turns into this, which turns into these things. It's like this whole big chart, unfortunately, and that's like
big one chart in the book.
Yeah, this graph is in the book, and then there's also this one. There's this one, and then there's also this one. Like, it's
never ending.
Yeah, most of these are saying like the exact same thing. It's just kind of learning to group these according to, where we'll see them and what they break down into. So, Yeah, and then some of this stuff will be a little bit easier. So like we'll talk about what is the defective enzyme, which of the following enzymes. Okay, the question: defective activity of which of the following enzymes is responsible for maple syrup urine disease? That's a question that you'll see. I think I actually had that one as a board question. So this is our branched chain alpha keto acids getting broken down. Alpha keto acid dehydrogenase complex enzyme. So the 3 branched chain alpha keto acids, as well as their precursors, accumulate in the blood and are distributed in the urine. So that's our branch chain alpha, this guy. If we remember branched chain amino acids, remember live on a branch, the valine, leucine, and isoleucine. I'll put this in order. Leucine, isoleucine, and valine. Defective metabolism of branched chain amino acids will lead to maple syrup urine disease. Yeah. Like these are just, it's just going to be straight raw memorization of like either you know it or you don't. So same thing here. Erythrose 4-phosphate is one of the precursors to which amino acid? So look at, where's our erythrose? Here we are, erythrose 4-phosphate from the pentose phosphate pathway, phenylalanine, tyrosine, and tryptophan.
Your pal Tyrone tripped you in the ring.
Yep.
I was gonna say they're aromatics.
Yeah, and really that's going to be like how you want to, if you remember these. Remember last trimester when I told everybody super specifically, hey, don't just check out on learning your amino acids. Do you remember that?
I
Yep.
do remember that.
Yeah, here's why. Because they come back. So if you remember a lot of those things, the live on a branch, your pal Tyrone, blah, 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 blah. To be an MCC, you have to have soul, a city of acid glutes, all that kind of stuff. If you remember those, this gets a little bit easier because then you can just write erythrose 4-phosphate, arrow, aromatic ring structures, or aromatic ring amino acids, right? And then we know your pal Tyrone you in the ring. If you can remember that, it's easier. So if a person's urine contains unusually high concentrations of urea, which of the following diets has he or she probably been eating recently? So when we look at urea, have you guys talked about urea at all? Kind of where urea comes from?
We are there now, I believe.
It looks like this is one that probably a question that bled over. Just understand, so urea is essentially ammonia.
Isn't
Right.
it protein?
What was that?
Isn't it when you have a high concentration of protein too?
Yeah, so urea is very similar to ammonia. Actually, let's look at this. Urea chemical formula. Urea is CH4N2O. Then we have ammonia chemical formula. We have NH3. So like you'll see later, like urea gets broken down into, or like we'll have like ammonia. We have ammonia. We have these other things, these nitrogen base. that then gets converted into urea and other things, because we know, like, having a bunch of ammonia in our blood probably isn't a great thing to have. So it gets converted between the two. So we'll see.
Talk about that in micro too.
Yeah. Very low carbohydrate, very high protein should be, yeah, our go-to with that. Lots of urea means lots of nitrogen. Lots of nitrogen means you have too much protein in the blood. You can also get high concentrations of urea from something called rhabdo. Chris, have you guys heard about that before? Rhabdomyolysis?
I have 2 friends who've had it.
Yep. It's essentially like when you work out way too much, and because you work out way too much, it essentially you break down a bunch of your muscle fibers, because like when you work out, when you move and do stuff, like you're making micro tears in your muscle fibers. So you do that way too much, and then all of a sudden a bunch of your proteins and stuff essentially are free floating everywhere, or your body's trying to like recycle them and trying to like do what it has to do, and it just can absolutely obliterate your kidneys from way too much protein. So you'll talk about this more as well in the future, but urea, nitrogen, protein, all that kind of stuff. High protein diets are really, really bad for the kidneys. So somebody who already has kidney issues should not eat high protein. Okay. Okay. If an amino acid is catabolized to produce acetoacetyl-CoA, it is said to be, we essentially already had this exact question, it is ketogenic. And if you remember, acetoacetyl, do you guys remember the other? Acetoacetyl was one of our ketone bodies. Do you remember any of the other ketone bodies? Acetone was one.
Acetone, the weird one I can't say.
Yeah, beta something.
Beta hydroxybutyrate.
Yeah.
I don't remember how to spell it, so just we said it out loud.
BHB. So. It's BHB.
Yeah, beta hydroxybutyrate or whatever it's called. Beta hydroxybutyrate. Yeah. In a recent COVID-19, I almost guarantee you this question is gonna be on the test. They still boards loves COVID questions as well. So like this was on the exam when I took the exam. I specifically remember this question. Okay, so in a recent COVID-19 pandemic outbreak, some patients admitted to the hospitals that they have low oxygen levels in blood, where they have shown an instantaneous in vivo biosynthesis of cytosolic gaseous product has been shown to improve blood flow in the areas of lungs still receiving air, and thereby increase the amount of oxygen flow in the bloodstream. That's a lot of words. What does that actually mean? Which of the following amino acids can produce this compound, as well as functions as a gaseous neurotransmitter? This is one of the things where it's just a super random detail about this stuff, where like otherwise you'd have no clue about this. So, yeah. This is arginine. So if you see this question, functions as a gaseous neurotransmitter, you'll probably see this question. You just have to know which one it is. It's not. I don't even think it's in the book. Okay. In a single step transamination reaction, using alpha ketoglutarate as one of the reactants, alanine would produce which of the following? So let's look at our whole little chart. What we've got here. There's our alanine. Let's see if alanine's anywhere else that we could work it backwards. It's going to be probably better in one of these charts, but we see pyruvate to alanine. So we're going to look at our answer choices. Pyruvate is going to be one of the answer choices. It's not here, not here. I'm trying to find where the other part of that reaction is. The answer is glutamate, pyruvate, and glutamate. Oh, that's why. Okay, that's why. My mistake. We looked. This is a two-part question. I was missing the second part. Alpha ketoglutarate. So we alpha ketoglutarate using alanine. The alanine goes backwards to pyruvate. The alpha ketoglutarate progresses to glutamate. Two-part question. Let's erase. Bam. In the treatment of diabetes, insulin is given intravenously. Why can't this hormone, a small protein, be taken orally?
B.
You say B?
C.
C? Yeah, it's C. The very low acidic stomach acid, and as well as the intestines, could literally just tear apart the insulin.
Which is why the only two appropriate ways of taking it are nasal and injection.
Yeah, which I don't know why this question's in here either. Some random questions in here. John's diet is very rich in proteins and very low in carbohydrates. Concentrations of which of the following compounds likely very high in his urine? We already kind of mentioned this as well. Yeah. Because protein equals nitrogen equals urea.
Question: urea is very acidic, isn't it? Or is it very basic? I can't remember.
I mean, urea itself, it has a good amount of hydrogens, and it has like, yeah, so it's, and this is NH3 plus, or whatever. So.
I was just curious because I had a patient a long time ago who had urine burns on their legs.
Yeah. So urea itself, because it's positive, because it is a positive ion, it's going to be more likely to, be lower pH and be more acidic. Okay, the disease phenylketonuria is described as which of the following? Again, this is just recognize the condition. So, defective phenylalanine degradation can lead to phenylketonuria, aka albinism. If you watch shows like House MD or like Grey's Anatomy, there's always an episode about phenylketonuria. I think in like all of the big medical dramas, you see this one here where essentially they describe it. Oh, like he's allergic to this specific, this specific amino acid. So this is literally, it's seen in a newborn. They typically notice it fairly quickly. It's very common to also be like an albino with that condition. So you can't convert phenylalanine to tyrosine. So literally the solution to this is to just not eat any foods with phenylalanine in it. So they literally have like a list of foods that are safe, and then they only feed the kid those specific foods. So it's characterized by which of the following? It's going to be the high levels. Oh, I guess it actually is a multiple, all just like a lie. If this was actually multiple choice, it would be all of the above. Because that is the answer. All of the above. You would see all of these. You'd have high serum levels of phenylalanine, accumulation of phenylpyruvate, Phenylalanine is not hydroxylated because that's the enzyme isn't there to hydroxylate it. And then high levels of it in the urine because, again, your body can't break it down, so it's just going to try and filter out as much of it as it can. Oxidative deamination of which of the following compounds directly produces ammonium ions? Okay, let's look back at our whole chart. Ammonia. I'm pretty sure I wrote this one in here somewhere. I didn't. Answer for this one is our glutamate. Hi, bud. Come here. You want to help me teach? Oh, you want to learn some biochemistry?
Start them young, Drake. Start them young.
Start them young. Okay. Here's another medical condition. You can write this down on our list of, hey, these are things that we just need to memorize because woohoo! Primary oxaluria type 1. It is defects in our glycine metabolism, which causes excessive oxalate production, which leads to one class of kidney stone formation and renal failure. The defective enzyme is glycine transaminase. So we have issues with glycine. The product that accumulates is glyoxylate. And we get renal failure due to kidney stone formation. That would suck.
Sounds like a bad time.
It really, really does. So
This
this
goes to
was...
show how bad oxalates are.
Yep, our oxaloacetate. Oxaloacetate crystals, which... for
Give you kidney stones.
Yep. Okay. Ring hydroxylation of which of the following essential amino acids produces tyrosine?
I can't remember.
Well,
I cannot remember this one.
first of all, let's think about, remember essential amino acids. Do you guys remember the mnemonic to remember essential amino acids?
Lucy loves lysine or something like that.
Well, this is essential amino acids, so all of them. So private, Tim, Hall are our essential amino acids. Remembering all of those. So this one, it's actually the guanine is the one that produces tyrosine. Sorry, let me see get my mouse to work. There it goes. Let's see if I have the... Okay, this is literally just, straight, hey, look at all of these individual things and start putting these into a big ol' chart.
Like Dr. Sarkar said.
Yeah, because I know it's in one of these charts. It's just, finding it. Comes through, there's tyrosine there. It's fine. We'll have to find it. You can start. What I'd probably do is I'd probably do it this way. Write out each amino acid. Like if I were to write out tyrosine, I would write out, then like find and discover as you study, as you read through stuff. Hi, bud. Yeah. as you continue to read through the material and study through the material, just like have a running list of like, okay, this is all the things tyrosine turns into. So you have, I'd probably make a little chart. So do the amino acid, do turns into by whatever. So this would be tyrosine. Actually, this would be threonine turns into tyrosine by ring hydroxylation. And that's how I'd start to make a chart. And just do it for all of them, and then study the crap out of it. Start this. This is probably another thing I'd say. Hey, start this now, so that way you have it before your test. Your test is next week, isn't it?
No, I think it's a week after.
Right. This is week 7, week 8, week 9. So if you have 2 weeks, about 2 weeks, start doing that. Okay. Surplus amino acids. We think with extra amino acids, we have extra protein, extra stuff in our body that we're not actually using. Where do those go? They're going to be used as metabolic fuel. Hey, bud. What's up? Yeah? Hey, can you go find Mom? Let's go find Mom. Go find Mom. Sorry about that. Usually I'm in a whole separate area, so he can't come and find me when we do tutoring, but yeah, so if you think about using them as metabolic fuel, it's the same thing with anything. Like if we have extra carbohydrates within our body, if we have extra protein, all of that eventually typically gets converted in one way or another to some form of energy. Tetrahydrobiopterin can participate in, I believe I have my notes. I have one of these written down as the specific cofactors. Yep, I do. Tetrahydrobiopterin does ring hydroxylation. So it's so we find our answer: aromatic amino acid ring hydroxylation. That could be another column to add onto our by using what is called the tetrahydrobiopterin. That's another thing that you can add onto a beautiful growing chart. Okay, the amino acids serine, alanine, and cysteine can be catabolized to yield which of the following? This again is just following the path back and forth. This one's going to be pyruvate. Maybe if it lets me. Jeez, I'll just circle it then. It's just following those charts. The disease phenylketonuria is described by which of the following? We already saw this one. Phenylketonuria is
All the above.
Yeah, all of the above.
Ooh.
Let's quick. We haven't found a typo really yet in the questions of Biochem 2 until this point. Let's see. Phenylketonuria. High levels of phenylalanine and phenylpyruvate or phenylketone in the blood/urine are accumulated. So yeah, this is that's gonna be wrong. We even saw above. All of the above is the correct answer. The genetic defect, or which of the following enzymes causes phenylketonuria? I'd probably also, the chart that I'd start to build and start to make would look like this, would be disease, enzyme affected. Most often it's an enzyme affected or cause, and then I put symptoms on the other one. And the book already kind of breaks it down like that, but I would start putting it in to a chart. So we have phenylketonuria. The phenylketonuria, the enzyme that is effective is our phenylalanine hydroxylase. Symptoms that we want to remember: vomiting, mental retardation are two of the more lasting, long, severe ones. And then we can even just write down these answers, those answers that we see above. High serum or urine, phenyl something or other. I'd start building that chart as well as for studying. Okay. The genetic defect, which was the one that he does it, the phenylalanine hydroxylase. And really, if you remember phenylketonuria, the phenyl, you can connect it with phenylalanine. Okay, the genetic defect in which of the following enzymes causes phenylketonuria? Is that the exact same question? Yeah, it's literally the exact same question. Nice. The function of glutaminase. I don't even see in the book. Glutaminase is the enzyme hydrolyzes glutamine to yield glutamate and ammonia. So here in our answers, should produce glutamate. And we also say this is main respiratory fuel of the intestine is glutaminase. What is the major cause of maple syrup urine disease? With maple syrup urine disease, do you remember which one that was?
Branch chain.
Yeah, good as the branch chain. If you want to try connect those even a little bit more, what was the mnemonic for branch chain amino acids?
Live on a branch.
Yeah, where does maple syrup come from? Maple trees.
Tree.
So live on a branch.
Quite literally.
Branches are on trees.
Maple is tree.
Make sap. Sap makes syrup.
You're horrible.
I love it. What is the product of enzyme catalyzed breakdown of glutamic acid. Glutamic acid, what's another? Glutamic acid is literally saying the exact same thing as glutamate. It's just sometimes they decide to make it glutamic acid. Yeah, and if we look at these, of all of these, which one sounds the most similar?
Alpha-ketoglutarate.
Yeah, alpha-ketoglutarate. When all else fails, like, look for actual similarity between words. Sometimes it works out. Okay, kwashiorkor. This is another one. I'm going to take a second to run through both of the kwashiorkor and the other one because these are always on tests. These were on my board exams, and these come up in many classes. So kwashiorkor is a protein deficiency, meaning that you're not consuming enough foods with the essential amino acids that we need to survive. So, for example, that you could be eating 8,000 calories of rice every single day, but because you're not getting any of the protein that you need, you become malnourished. So it's a protein issue, not a calorie issue. And that's kwashiorkor. Marasmus is the other one, and that is both protein and calorie deficiency. And if we look at, let's see, the difference between them. Let me see if it'll let me here. So here is kwashiorkor. You can see like the big extended puffy belly. That's because they're eating something that's not, they don't have enough protein, so they can't, like, you know, produce the muscle, produce all the stuff that they need to within their body, and they get an enlarged fatty liver. Whereas marasmus, where they don't have enough calories or protein, they get just overall completely skinny. It's like this child, like, overall looks like meat-wise on their bones, like looks like healthy enough, but usually they'll have like the distended belly that doesn't look, that just kind of makes kids look sick. And then if it's calorie issue as well, they'll literally just be the skin, like skin and bones. So we look at kwashiorkor. It is a disease in which fatty acids are oxidized. It can produce negative nitrogen balance in humans. It is not caused by diet sufficient protein. This is the tricky one. Put those in the not, so if you're not careful. You just be careful or not. So it is caused by diet sufficient protein. As far as nitrogen balance, this is referring to is nitrogen in versus nitrogen out. So within our bodies, we need to have a balance of nitrogen coming in versus nitrogen going out. Just like we need a balance of everything else, you know, coming in versus going out. We need a balance of oxygen coming in versus carbon dioxide going out, water coming in versus water going out, etc., etc. So a negative nitrogen balance means that we are losing, like, due to like bodily functions and the, you know, continuing to go to the bathroom, do the things, we're losing a certain level of nitrogen all the time. So, well, if they're not getting enough protein, they have a negative nitrogen balance. If somebody is like a bodybuilder who is slamming 600 grams of protein every single day, like protein shake after protein shake, they would then have a positive nitrogen balance. Okay. Next one. Which amino acid is produced in a transamination reaction when alpha-ketoglutarate reacts with another amino acid such as glutamine? He asks a lot about this one. I think it just likes it because of the way it sounds or something. But a lot of alpha ketoglutarate kind of stuff. Which amino acid is the immediate precursor of methionine? The answer to this one is homocysteine. This is going to come back up.
Quite a bit.
I don't know if it's in this class or if it is more just a boards thing. But there is something called, there's a reaction within the body that's super, super important. Let me see if I know it's here somewhere. Here we go. It's called the methylation cycle. I don't think they get super deep into it in this course, but I'm going to go over it just really briefly here in case it comes up a little bit later on down the road, or if it is in the book and I just don't quite remember right now. So the methylation cycle, you have an enzyme called methionine synthase, which is activated by B12 enzyme. So this is why, vitamins B9 and vitamin B12 are super, super important for regulating this cycle. So basically you have methionine. Methionine gets demethylated to homocysteine. And then methionine synthase can return homocysteine back to methionine thanks to our B12 cobalamin. So essentially what happens is, this is for like we'll have like extra methyl groups throughout the body, and if we don't have, hi bud. Okay. Come here, bud. Okay, give me 1 sec. I'm gonna mute real quick. Say oh, don't unplug that. Let's say prayers with the family real quick. I'll be right back.
Lily, come. Come here, Lily. Lily, get over. Lily, come. Come here.
Okay, I'm back. Okay, so saying we need to essentially get rid of the methyl groups that are in our body, and the point of this is essentially to pass them, going between methionine and homocysteine, because then that homocysteine can continue and go down into other stuff and do whatever it needs to do. And yeah, I won't go too much deeper into that. We'll see if we have any questions on it. If not, I know you learned it. You go over it more at some point.
Homocysteine's an interesting one though in the long term.
Yeah.
I actually have to take it. I have to take supplement for it because I don't methylate. So.
Which amino acid is the immediate precursor of tyrosine? We think about these guys. Tyrosine is one of our ring structures. We look at these. Easiest way to remember. Look and see which other ones are potentially similar to it. That's one of the tricks is things tend to break down or appear similar to what they are. So, like if it's already a ring structure, it's going to usually turn into another ring structure. It's usually not going to go, if it's a branched chain amino acid, it's more likely to turn into a branched chain amino acid just because things are easier to change just a little bit than to change a lot. Okay, the enzyme that catalyzes the conversion of glutamine to glutamate, that was our glutaminase that we talked about earlier. Jeez, my computer is, one of the USB ports is shot, so my mouse keeps fidgeting and freaking out, but my mouse pad on my keyboard doesn't work, so woo. Okay, which of the following amino acids is nutritionally essential in humans? Mnemonic are private, Tim, Paul. And we even look at our amino acids, all of our essential ones. Phenylalanine, valine, tryptophan, threonine, isoleucine, methionine, histidine, arginine, leucine, and lysine. So we go and we take a little look. Our answer in this case is tryptophan. What does it mean that an amino acid is essential in humans?
Means the body makes it.
I'm glad I asked this question. It's the opposite. It's essential.
We need to ingest it.
Yeah, it's essential that we eat this. So, essential equals the body cannot produce it, so we have to consume it in food. This was always, he often would ask questions about this, like what does it mean about be essential or not or whatever, and a lot of people constantly flip-flopped on it, so myself included. Okay, which of the following amino acids is glucogenic? Again, we look at it. Gluco. When in doubt, pick the one that sounds the most similar. Glucogenic, meaning it has glucose base, glutamic acid, aka glutamate. Thinking back to physiology, what does glutamate do as a neurotransmitter? This will pop up on a test somewhere. Remember, glutamate activates. So it's an excitatory neurotransmitter. And then the opposite one, glycine inhibits. Okay. Which of the following amino acids is not derived from glycolysis? We'll take a look at our little chart all through here. Alpha-ketoglutarate, let's split this right here. Not from glycolysis. Let's look. Alpha-ketoglutarate, arginine, proline, glutamine. Cross off arginine. That one is from glycolysis. Actually, hold up. I might have wrote that down wrong. Yeah, I did. Actually, we can highlight that because not derived from glycolysis. This is not from, arginine is not from glycolysis. It is from the TCA cycle. So we look at the other ones, glycolysis, there's glycine and cysteine. Pyruvate from glycolysis, isoleucine, leucine, valine, alanine. I didn't see serine. Oh no, serine is right there. Serine, glycine, cysteine, and then alanine was right there. Okay. Which of the following amino acids is strictly ketogenic and produces acetyl-CoA? Strictly ketogenic. Ketogenic are leucine. If I'm not mistaken, I think if we go back to Biochem 1, that was one of the categories that they gave us, right? Yeah, and actually, if you have my notes as well, some of these, the ketogenic. I think you mentioned this before. Lucy lies to get the keys. Leucine and lysine are our purely ketogenic ones. Aspartame. Yeah. As you can see, a good chunk of this stuff, the amino acid derivatives, a lot of this stuff directly applies to the boards. You'll see these questions there. So, which of the following acids is strictly ketogenic? Again, leucine, lysine. Good. Which of the following amino acids is the precursor for the skin pigment melanin? So if we think there was a condition that we talked about, right? That medical condition that if you don't have this, you're more likely to be, whatchamacallit, to have albinism. And I won't go down that road. That's secondary, tertiary level question. He's not going to ask that. But skin pigment melanin is tyrosine. What I was going to say is there's the issue with the defective phenylalanine degradation, and there's a whole process, like the way that it's connected. You could get there, but it's going to be too much for. It's easier to just make a nicer chart and memorize instead of getting through doing it that other way. Okay, the precursor of melatonin. Melatonin is going to be tryptophan. If you have, these are my board one notes, the tyrosine and tryptophan. These two are the really, really important ones. Is what I was saying. So phenylalanine converts to tyrosine. So if you have deficiency of phenylalanine hydroxylase, you get PKU, can't convert to phenylalanine to tyrosine, and you get albinism. Yeah. So tyrosine is responsible for making the melanin. Tyrosine is responsible for making our catecholamines, dopamine, norepinephrine, epinephrine. Tryptophan does our serotonin, melanin, and melatonin. So tryptophan and melatonin. Body naturally makes melatonin for our circadian rhythm type stuff. Which of the following is the precursor to dopamine? You just talked about this. And these questions, these ones specifically, these ones are going to be board style questions every single time. They love the tyrosine, tryptophan, phenylalanine type questions. Which of the following amino acids? Let me actually do this. I'm going to just copy paste this. Into here, and I'll send you guys that. So, okay, which of the following amino acids is used to synthesize cysteine. This one's going to be serine. Again, it's just make a chart, go through this, turns to this, turns to this, turns to this. Which of the following amino acids is used to synthesize glycine? Serine. Serine goes to glycine. Which of the following can donate the sulfhydryl group for cysteine biosynthesis? We think about the rule of thumb. One cysteine. Cysteine is going to be MCC. You have to have Sol. MCC is sulfur. Methionine, cysteine, and cysteine. Only one that fits close enough with all of those, the homocysteine. Which of the following coenzymes is used for aromatic amino acid ring hydroxylation? We talked about this one as well, because we gave the example as well. The tetrahydrobiopterin does our amino acid ring hydroxylation. Which of the following compounds is an alpha keto acid? Alpha keto acid. In this case, this says acid. Typically, if something's an acid and it's converted to something else, it'll have an 8 at the end. If not, I'll just have an ic and then an acid. So sometimes the most obvious answer is the right answer. Which of the following compounds is an alpha keto acid? Again, same thing. Not an acid, not an acid, not an acid. Oxaloacetic acid is the only one that's an acid. Which of the following compounds is required to synthesize serine from glycine? This is going to be our tetrahydrofolate. Let me pull back up our cofactors. Our peroxidyl phosphate, vitamin B6, is for transamination. Tetrahydrofolate is accept or donate a 1 carbon group. And from serine to glycine, we lose 1 single carbon. Which of the following compounds is used in a direct transamination reaction to synthesize alanine? We find where is our alanine right here. Alanine goes to pyruvate. So a lot of the arrows that you see, like most of them go, or all of them essentially go both ways. So like if pyruvate can turn into alanine, valine, leucine, or isoleucine, any of these can be turned back into pyruvate. So that's an important characteristic to make sure to mention. Okay, which of the following conditions can produce a negative nitrogen balance in humans? We talked about this one. Which of these causes a negative nitrogen balance in humans?
Foreshore.
Yeah, kwashiorkor. Remember, kwashiorkor is just a deficiency in protein, but not of calories. Marasmus is both deficiency of protein and calories. Which of the following dietary requirements is involved in nitrogen balance? Which of the foods?
Proteins.
Proteins.
For some reason, I read the list twice and I didn't see the word protein. Which of the following enzymes oxidatively deaminates glutamate to produce ammonium ion. This is a new one that we haven't seen yet. It's glutamate dehydrogenase. Trick here, remember, oxidatively deaminates oxidation. An oxidation reaction is always going to be a dehydrogenase. And 9 times out of 10, again, you're going to see something like an NADH or FADH or something that's going to be accepting that hydrogen. Which of the following essential amino acids is required to synthesize the amino acid tyrosine?
Phenylalanine.
Phenylalanine.
Phenylalanine, because both of them are ring structures. Nice. Tyrosine, what's tyrosine responsible for? What does it go off and create? Starts with an M. Skin pigmentation.
Melanin.
Yeah. Melanin. What's the medical condition that you get if you are unable to break down phenylalanine?
Maple syrup disease. Is that right?
Phenylketonuria.
Yeah, that's right.
Phenol. What's it?
Phenylketonuria.
Yeah, phenylketonuria. You also get albinism. Because remember, maple syrup disease. We get maple syrup from trees. Trees have branches. So that's...
Live on a branch. That's the branch
Yeah.
ones. Branch chain amino
So we
acids.
have a branch chain. What's it called? The branch chain alpha keto. Branch chain alpha keto acid dehydrogenase complex is not working. And so you get...
Cannot break it down.
Yeah.
Yeah.
Which of the following intermediates of the citric acid cycle is used to directly synthesize aspartic acid, aka aspartate? So we look here. So the citric acid cycle, that's probably another way you can organize all of this, is you doing citric acid cycle, or like where they come from. So either from glycolysis or from the citric acid cycle, and like what's their common link. Sorry, it was aspartate is what we're looking for.
So it should be asparagine, I think was the answer choice. No, it's
Oxaloacetate should be here. Alpha ketoglutarate. Here.
Oh yeah, I see it.
There it is. Aspartate.
9. Yep.
I just can't read. Which of the following is not true? Glutamate dehydrogenase is a mitochondrial enzyme, or it is a cytosolic enzyme. Glutamate dehydrogenase has to do with glutamic type stuff. That means it is a mitochondrial enzyme. So what is false is that it is a cytosolic enzyme. Jeez, these honestly, I feel like this whole unit is make the charts that we talked about, and then just review these questions in like a Quizlet format multiple times and call it a day. Like that's really like going to be the best way to prepare for this chunk of material. Which of the following is true? Yeah. Which of the following is true for glutamate dehydrogenase catalyzed reaction when glutamate is the substrate? So glutamate dehydrogenase, remember it's going to dehydrogen stuff. If we're dehydrogening, we're taking away electrons. Oil rig. is loss. Reduction is gain. Dig back deep in the brain for that. So glutamate is oxidatively deaminated. Which of the following is true of arginine? This is again knowing, does it come from the TCA cycle? Does it come from glycolysis, etc., etc.? In this case, arginine is not directly derived from glycolysis because arginine is from the TCA cycle. Which of the following products is accumulated in body if methionine is not degraded enzymatically? We mentioned this briefly when I pulled up the other thing. Yeah, homocysteine. Homocysteine, if it's not degraded from methionine, is not degraded enzymatically, then we end up with a whole bunch of extra homocysteine in our blood. Which of the following statements best describes the function of glutamate dehydrogenase, GDH, enzyme in amino acid metabolism? And we've already essentially answered this question multiple times. It oxidatively deaminates glutamate. So we've had 3 or 4 or 5 Linus questions about that now specifically. Probably in some form like this is going to be on the test. Why
I agree with that.
Yep. So why are blood levels of alanine and glutamine much higher than other amino acids? So this one, if we think back, I'm pretty sure it's biochem. Remember when we talked about muscles and how when we break down muscles, we release certain amino acids and stuff into the blood as well. Do you remember talking about that?
Yeah, kinda.
It was
Kind of.
It was a while back. I'm pretty sure it's in biochemistry. Yeah, it is biochemistry that we're talking about. It's like a super minor part in Biochem 1, where it's just like, hey, like, this is the stuff that comes from off of the muscles in order to go through the blood and do whatever, this, that, and the other thing. So in this case, we have an alanine and glutamine kind of exchange. The alanine and the glutamine are what carry nitrogen through the blood to get it to the liver. Blank, one of the intermediates obtained from the blank pathway, can synthesize histidine. Histidine, if we remember, what does histidine sound like? Well, which of the amino acids does it sound like?
Purine.
I should go forward. Oh, my brain is getting something. Okay. Yeah. On Tuesday, we still did biochemistry. Histidine going forward. Sorry. Histidine going forward is histamine. So I got biochemistry and physiology swirling around in my brain. So trying to keep them separate. The histidine goes into histamine. Histidine is the one special one that comes from the ribose 5-phosphate from our pentose phosphate pathway. So we look, our pentose phosphate pathway, that's the only answer choice for our histidine, which turns into histamine, which if we look at eicosanoids from last chapter, if we let's say if we no, I'm not gonna. That's too deep of a question. We'll get there eventually. With other courses. Okay. All in all, like you start to see, because we got through all 58 questions in about an hour, which, you know, a lot of repeat kind of stuff. And I feel like in general, you can kind of start to tell what sort of things he's going to like on the test. He's going to ask you questions about the urea stuff. He's going to ask you questions a lot about like alpha ketoglutarate. So if I'm not mistaken, even in biochemistry 1, he liked questions about alpha ketoglutarate.
Go party.
Yeah, nitrogen balance, all that kind of stuff, the specific diseases. He'll have multiple questions on like maple syrup disease, the alkaptonuria, phenylketonuria. He'll have one question each on like the primary oxaluria type 1 and how you get kidney stones and renal failure. He'll probably have one question on like the methionine degradation. It's safe to assume he'll probably have one question from each of these conditions. At least 1 or 2 questions from each of those. So hyperprolinemia type 1 and type 2, he usually has one question about those as well. So yeah.
Can you send those Linus questions to me, Drake?
Yes, sir.
Thank you.
Is it okay? Are you on your laptop right now, or are you on your phone?
I'm on laptop.
Okay. If I throw them in the chat, are you able to see them there?
I can't see the chat for some reason. Like I've never been able
You gotta
to.
click the chat button.
If you don't see the chat button available, you need to join the tutoring page that this is on.
How do I do that? I don't know how.
If you go in team, I'll actually show. If you go to teams, go to all teams right here. Just click this teams button. Join or create team, and you'll. Let me see if I can pull a join code. What's it? Maybe this will work. If you can go to join or create team, join, and type in tutoring services, drop in tutoring. So tutoring services.
I think I found it.
Drop in tutoring. It probably won't show up for me because I'm already in it.
Okay. I think I joined it. Like I typed in the thing and it popped up and it said join team, so I joined it.
Join. Okay. If you actually go into that team, you should be able to go down to, I guess right now we're in general. So if you come to general, you should be able to see the meeting going on right now, and you can see details. And let me do this. Oh, gotta open the chat window. If I drag this into the chat window, downloading, send, you should see it pop up right here.
It still doesn't show the chat window, but it does say that I joined.
Okay, well,
I don't know.
for now, also, I just threw it into, I'm throwing it into GroupMe right now and sending
Okay.
it. Yeah, just send it your way on GroupMe.
Thank you.
Well,
I'll probably have to
Hey, Joe.
refresh and then it will.
I was gonna say you probably need to refresh it.
So many biochemistry memories.
Hey, there it goes. I found it.
Got it?
Mm-hmm.
Okay. Just to be safe, I'm gonna. What is this? Is amino acid. Can you open it up on your end and double check and make sure that it's the filled out one with extra stuff?
Yeah, it is.
Okay, good. I don't. We got through that one pretty quick, guys.
Very
I'll
nice.
leave you.
Very
That was
nice.
nice. It's so light out.
Yeah. I'll let you guys go. Keep studying for clinical imaging or whatever tomorrow, and then.
I will say it's a miracle. We
What was
finished
that?
before it got dark. It's a miracle. We finished before
Yeah,
it got
for
dark
real.
out.
All right, you guys. Have a
Bye.
good day. Enjoy it.
Thank you, Drake.
You too. Thank you, Drake.
Let me know if you guys need anything, okay?
Appreciate
Thanks.
it.
Bye.